the thing that's driving small cells at the moment, and what's driving small cells at the moment, is applications. And it's not just typically the kind of applications that you and I use, it's applications that different demographics use, like for example Snapchat, Vine, those sort of applications, 6-second videos. Snapchat is now the third used social media application in the market. And it's not necessarily something that I think a lot of people in this room will use. But it is what's kind of driving the need for small cells. So we always have to kind of bear in mind that it's really the applications that's driving the requirement for coverage and capacity in a small cell or HETnet environment. How are we doing with the slides?
I'm sorry,
Okay, I'll keep talking. All right. I think I'll keep talking. All right. So look, one of the major requirements for small cells is, to me, moving from kind of femto and moving into capacity environments. There's some smart fellows called Shannon and Hartley that created a formula which said that there was a maximum rate at which you could transmit information in the presence of noise. That still holds today, in an air interface. And what does that mean? That means that if you've got interference and noise, and at the same time we've got traffic, potentially kind of doubling every 2 years, doesn't really matter what that is. Capacity to me is the key driver. Now, a couple of stats. 50% of traffic generated is done by the most extreme 1% of users. Okay, have a think about that. 50% of the traffic is generated by the top extreme 1% of mobile users. 90% of traffic is generated by the top 10% users. Alright? So if you put that together with traffic rate increases, who's generating the traffic and where those people are, and the fact that we have a limit on how much traffic we can transfer across the air interface. We know that if you then put small cells in place closer to the user, and particularly the users that are using up most of the bandwidth, and if you can geolocate that information, so basically put it in the right place, you're going to solve a lot of the major problems you've got. So that really is what kind of generates if you think about what's the kind of key need, which is locating small cells, which is where am I going to put these small cells, and being able to kind of surgically and precisely position those small cells to where the major users are, and where you're going to get the least interference and noise, and closer to the user, you're going to get a lot of volume, because it is down to the kind of business case of doing that. Now, then when you're going to kind of turn up small cells, you're going to have to imagine this. We do actually have the slide that I was going to show you. Anyway, use your imagination. When you're turning up small cells, it's all about trying to kind of minimise the cost of deployment. And here, one of the kind of major changes, whether it's kind of DAS or small cells or Wi-Fi or HETnets or that whole range of things, it's the combination of RF and fibre coming together. Right? So we've got a lot of fibre coming in place. I think it's been kind of talked about both front haul and back haul, and how do I kind of manage that, particularly now if it's in the front haul. And this can be used, for example, in a DAS environment as well. I might be using, for example, CIPRI to carry the information. Right? So how do I get access to the RF information over that CIPRI link that I used to get access to over the coax link? So this network turn-up, this kind of whole RF and kind of fibre worlds coming together is really a kind of important part when typically an engineer, for example, is not going to be a specialist in both areas. So that kind of RF over CPRI technology is really important. So, talked about location. I hope your imaginations are working through this all right, right? But talked about location, talked about kind of network turn-up. Now we have to kind of think about what do we do in terms of kind of doing some of that service testing as we're kind of turning up. So there's tools, for example, available that you can use for example, like 3D mapping, particularly useful, for example, for indoor DAS environments, where you do kind of 3D mapping of an indoor environment, and gives you a kind of view as to kind of where you're heading. But here's the important thing, right? Being able to do service testing and get RAN metrics at the same time as you do your cell site kind of turn up and optimization. So it means that basically you can do active service testing, because you don't necessarily have a lot of users if you're bringing on a cell site, right? So you need to kind of generate some traffic, but have those kind of RAN metrics at the same time, and marry the combination of that. Now, particularly with kind of indoor, where you're going to kind of DAS environments, is one key thing that you always have to be kind of conscious of is macro ingress. Why is that important? Because if you're setting up, for example, like a DAS environment, you know, an indoor, maybe it's a stadium, a ball, or whatever, you can do a kind of walk test, and it can determine. Oh gosh, right, I'm nearly finished. You can. It's nice to see them anyway. You can determine